Hi students, welcome to another mathematics session. This is Form 3 Mathematics, the topic of relation, and we are going to focus on linear inequality relation. So with linear inequality relation, you are going to actually understand that a linear inequality relation represents a relationship between two variables that can be graphically represented on a coordinate plane. The graph of linear inequality will shade the region that satisfies the inequality. So here is a general guide on how to graph a linear inequality in two variables such as y and x. So first of all, you have to know how actually the linear equality will look like. And with the equations we have here, at least you can get idea that it is possible to have y is less or equal to mx plus c. This is just a general formula. And you have y a greater or equal to mx plus c, or y is less than mx plus c, and another one is y is greater than mx plus c. So these are kind of general linear inequalities we might have while you are dealing with actually with linear inequalities. So expect to see this inequality sign most of the time. This one here meaning less than, and this one greater than, the other one less or equal to, the next one being greater or equal to. And know that with less than or greater than, when we are going to plot a graph, we are going to use dotted lines, while when you have greater, less or equal to, or greater or equal to, in a given inequality, while we are sketching a graph, we are going to use solid line, dear students. So how to draw a graph of linear inequality? First of all, the easiest way for you to be able to do this, write the inequality in slope-intercept form. It is not already actually done. We are not yet done actually. By just writing, you are not yet done. So the slope-intercept form of a linear equation is y equals to mx plus c, where m is the slope and c is the y-intercept. So if your inequality is not in this form, you are going to rearrange so that you are going to have the same form. The important part, you make sure that you have y equals to mx plus c, dear students. Well, so for example, you might be given an equation like this one here. For simplification case, we just did actually in the form of y equals to mx plus c. And how do you do it actually? You're going to make y the subject. So I'll be having 2y is less than negative 3x plus 6. We'll be dividing by 2 throughout. So we'll be having y less than negative 3 over 2x plus 6 over 3, which is actually equals 6 over 2 equals to 3, dear students. So this is how we are representing a given inequality into slope y-intercept form. We are going to second step. So the first step, we say that you present actually the given inequality into slope y-intercept form. Then you're going to graph the corresponding line. And here it is very important. Treat the inequality as an equation and graph the line it represents. You're going to treat the inequality as just an equation, and you're going to draw actually the graph as it is. But you understand that with inequality restrictions like this one here, you're going to use dashed line. And if you have inequality that include, actually, it means you have less or equal to or greater or equal to, you are going to use a solid line. So this is dashed line and this is a solid line, dear students. Another step, determine the shading region. So you're going to identify whether the solutions lie above or below the line for a two variable inequality. So this is determined by inequality symbols. So less or equal to means below the line, and when you have greater or equal to means actually the required region is going to be above the line. Then the next step, you are going to shade the appropriate region. So shade the region on the side of the line that satisfies the inequality. You are going to shade the side of the line that satisfies the inequality. So use different shading pattern for dashed line than for solid line. So I think these two important points here has to be noted, that you're going to shade a region on side of line that satisfy the inequality, but also you're going to use different shading pattern for a dashed line than for a solid line, dear students. And the last point, you're going to check a test point. So you're going to pick a point not on the line and check if it satisfies the original inequality. If it does, then you're going to do what? You're going to shade. If it does, the shaded region is correct. If not, you may have shaded actually the wrong region. So testing is really important, dear students. So let us go now to examples. So this is an example from our book. We are using here, this is a Thai book, the official book students actually are using in Form 3. So with this, we are going to go to these examples. The good side with this note, I can easily sketch a graph of this inequality here by using my computer. But the point is not really important. You're going to observe all the procedures so that you're going to sketch the graph, dear students. So it means for this one here, you'll be sketching a line y equals to x, and because we have inclusion sign, it means you're going to use a solid line, dear students. So I will be using this equation as it is. I'll be using this equation as it is to sketch the graph, dear students. And here we go. With OneNote application, you can just pick actually the equation as it is. When you do that, the computer is going to sketch for you. And so you're going to, let us see how we're going to sketch it. So I'll just put equation here, and I'm going to type my equation. It is y is less or equal to x, and this equation we are going to include it in the math part, dear students. So I'm going to include in the math part, and you can see that with this one, you are going to be given actually some options. So graph inequality, you can see that this is a graph of given inequality, dear students. So I'll be inserting the graph here. I'll be taking the graph, and it is already actually there, dear students. So this is the graph of our given inequality, and you can see that with inequality sign we have here, it means the shaded region is below the line as the inequality sign here indicate. And from the graph, what is domain, dear students? Domain is going to be all real numbers, and range will be actually all real numbers, dear students. We go to example number 2. So we are done with this one here. The important part, you are going to express actually your equation into slope y-intercept form. Then after that, you're going to treat it as a normal line. So you're going to sketch a graph, but understand that if it is, if actually the inequality sign include equal sign, then you're going to treat it as a normal solid line. Otherwise, you're going to consider it as a dashed line. The next one, dear students, so here the next one. With the next one, now I'll do the same. I'm going to write this equation here. It is y less than x. So I'll be sketching this graph with mathematics approach of this OneNote application, and here it is, dear students. So you can see that actually we have dotted lines. You can see easily that we have dotted line, and we'll be putting the graph here, and you can see actually how the graph is looking like. So this is our graph, dear students, and you can see that we have actually again dotted line with actually shaded region being below the line. I continue with the next one. The next one was this one here. So this is the next one. So how do we sketch it? So bear with me. I'll be just writing equation as it is. An apology. So I'll just put actually equation as it is. So it is y is greater than minus 2xc is greater y is greater than an apology. Y is greater than 1 minus 2xc, I can say. So here the equation, dear students, with this equation you see that there is also a dotted line. There is also a dotted line here, as you can see, and the shaded region is actually placed here accordingly. So I will just place actually the equation as it is. From here, I'm going to insert the graph, and there it is, dear students. So that is the graph of our inequality, and you can see that actually a shaded region is above the line, dear students. I proceed with the next equation, and so from all these you can see that domain is going to be all real numbers, dear students. So the last one for this session, not the last one, of course, we'll be having also another question, but for this one here, you have now two inequalities. You have x plus y is less than 2, and y is greater or equal to 2. So I'm going to consider two equations. So it means you're going to sketch a graph of x plus y equals to 2, and you're going to consider also y equals to 2. So simply, without using the computer, x plus 2, so it will be having 1, 2, negative 1, negative 2, 1, 2, 2, comma 2 there, and 2, comma 2, and you can have actually a straight line there connected, dear students. So this is a line. So this is actually x plus y equals to 2. And also we have y equals to 2. So y equals to 2, we're going to have another line here, y equals to 2. So it's going to be again a solid line. So there it is, a solid line. So this is actually y equals to 2. So now you'll be having actually a number of regions to test, and you're going to actually shade any region which satisfy all these two equations together. So for example, the first region, I can consider this region here, and we'll be testing 0, 0. So with the 0, it is true that 0 is less than 2, and 0 is less than. So it means, dear students, with the first testing, we have realized that the region to be shaded is going to be this region here. So this is the region to be actually shaded. So what is domain and range? I think this is very important, that domain is going to be all real numbers. As you can see that x is extending from negative infinity to positive infinity. So x will be all real numbers. But to range, you have to be careful now with the range, because y value will be starting from 2 going to negative, so it will be y less or equal to 2, dear students. And now we are going to proceed to the last question for today's session. So the last question for today's session is, we were given a graph, and you are supposed to determine the inequality sign of these, of these lines, linear inequalities given. The first thing to check here, as you can see that we have actually a dotted line. So it is either greater or less, greater than or less than. And because the region shaded here in this one here, I'm going to pick any point, and this point is going to be 0, 4. So with 0, 4, I'll be checking the first equation from x plus y. Then here you have 2. So putting x plus y, you have 0, 4, it means 0 plus 4. We know that 4 is going to be less than 2. So here, actually the sign is going to be x plus y is less than 2. With with y equals to 2x, having y equals to 4, 4 equals to 0, so you'll be getting actually here that y is greater than 2x, dear students. So you can see that now the solution, the inequality, find the expression of relation. So the expression of relation will be contained in these two expressions. So we are going to combine them together, dear students. So we'll be having R is pair of ordered pairs x, y, such that x plus y is less than 2 and y is greater than 2x, dear students. Now what is domain? For domain, we'll be checking again the nature of the graph, and from the graph you can see that the x values will be extending from negative infinity to positive infinity. So domain will be all real numbers, dear students. And what about range? Range, we'll be checking y values, and we can see that actually y is all real numbers such that y is greater than intersection actually of these two equations. So the first equation here, we have to check actually the y values here. So I'll be having x plus y equals to 2, and we're having y equals to 2x, meaning that x plus 2x equals to 2, 3x equals to 2, x is 2 over 3. You put back 2 over 3, y will be 2 times 2 over 3. So it is 4 over 3. You can say that y is greater than 4 over 3, dear students. So this is how we are solving these kind of questions. And the discussion was, dear students, on linear inequality of relation. Until next time, dear students, I wish you all the best in learning journey. Mathematics is meant to be solved so that you are going to understand. So make sure you solve as many questions as possible. See you in the next class. Peace.